Today, I'm going to show you how to build a full blockchain application step by step, a decentralized finance or DeFi app. This is one of the hottest trends in blockchain right now. I'm going to show you how to create your own DeFi app, a decentralized bank where users can deposit cryptocurrency and earn a competitive interest rate on their funds that's much higher than their traditional bank account. And I'll even show you how to extend the project where they can take out loans against the money, just like all the other hot DeFi apps out there right now. I'll walk you through everything from start to finish. Setting up the app on your computer, creating the smart contract with the Solidity programming language, deploying your smart contracts to a blockchain, and then also creating a website so that people can connect to the application and use it. And don't worry, you don't have to be an expert to get started today. You don't have to know anything about blockchain. You really don't even have to know anything about coding. I can show you everything as we go along in this tutorial. So before we get into that, if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. And I put a lot of time and effort into this particular tutorial, and the only thing that I ask in return is that you like this video and subscribe to this channel. That really helps these videos out so that more people can learn about blockchain. And if you like this video and you want to take the next step, or hey, maybe you just want to take a master shortcut entirely right now, I can show you how to become a blockchain master step by step from start to finish over at dappuniversity.com/bootcamp. Here's a quick preview of the application we're going to build together in this tutorial. This is a blockchain-based bank where you can deposit cryptocurrency into it. And whenever you do, you earn interest. That's one of the cool things about blockchain technology is you can become your own bank with cryptocurrency, and you can incentivize other people to use your application by giving them higher interest rates than they could in their own traditional bank accounts. This is part of a larger trend in blockchain technology called decentralized finance, or DeFi for short, which is basically taking traditional financial products and porting them over to the blockchain. Things like savings, loans, derivatives, trading. And in this video, we're going to build a DeFi app on the blockchain that is this digital bank. And you'll see how all this works step by step. So let's first look at a diagram about how the application works. Let's look at how the application will work. So we'll use our web browser and we'll connect to a website that we will create in HTML, CSS, and JavaScript. And that's pretty typical if you're going to follow some other development tutorial, maybe like a website coding tutorial. You would build a website that is coded in HTML and CSS and JavaScript. But here's where it differs. A lot of times those applications will talk to a backend server where all the code and the data will live for the application. But this is different. Instead of talking to a backend web server, we're going to talk directly to a blockchain. And this is a blockchain that we'll install on our computer and run locally. It'll be a development blockchain. And we'll create all the code for the bank inside of smart contracts. So smart contracts are immutable pieces of code that are deployed to the blockchain. They are the building blocks of blockchain-based applications. We're going to write them in Solidity, the coding language for writing Ethereum smart contracts. And Ethereum is the blockchain that we'll use in this tutorial. And one other big way this is different from web development is in order to talk to the blockchain, we need a special browser extension that will be our cryptocurrency wallet, because we must have this wallet installed into our browser in order to turn this web browser into a blockchain browser. And then we'll use a special library to turn our website into a blockchain website in order to speak to the blockchain and interact with the bank that we'll create in this tutorial. So if you're brand new around here, let's clear up one last question, which is, what is a blockchain? Well, it's a global computer. But in order to understand exactly, what it is and how it works, let's answer the question why we need a blockchain in the first place. So why wouldn't we just build a regular web application with a backend web server and a database? Well, in order to create a money, we're actually going to create a cryptocurrency in this tutorial. In order to create a cryptocurrency, we don't want a single individual to have full control over that cryptocurrency. We want it to be deployed to a decentralized network. That's exactly what a blockchain does. So you can see this diagram here. These are all nodes that are on the blockchain that talk to one another. Each of these nodes is a computer that shares a copy of the code and the data on the blockchain. So the code for the cryptocurrency itself, and also the data on the blockchain, how much cryptocurrency, each person has. It also facilitates the transfer of cryptocurrency, because anytime cryptocurrency changes hands, the nodes on the network must come to consensus about that transaction before adding it to the blockchain. So all these transactions on the blockchain that make up account balances that are responsible for verifying cryptocurrency when it's transferred, all these transactions are contained in bundles of records called blocks, which are chained together to make up this public ledger, hence blockchain. All right. I know that's a really quick explanation, but I think it'll all become a lot clearer as we jump in and start coding. So let's go ahead and do that. But before we can do that, we need to install some dependencies on our computer first. The first dependency is Node.js. This is going to give us a way to run JavaScript on our computer, and it's also going to give us npm so we can install all the packages for our project. So you can see if you have Node already installed by going to your terminal and typing node-v. I'm currently using version 10.19.0 for this particular tutorial, and I highly recommend that you use the exact same one to follow along. If you're an advanced developer already, you understand how to use Node versions, you can use whatever version you want to as long as it works. But if you're a total beginner, I highly recommend using this exact version to guarantee that your code will work. So you can download Node directly from the Node.js website, or you can use a package manager like Homebrew on a Mac to do brew install Node. The next dependency you need is the Truffle framework. This is a suite of tools that's going to allow us to create smart contracts on our computer with the Solidity programming language. We'll be able to write tests for them, deploy them to a blockchain, and connect to our development blockchain Ganache, which we'll install here in a minute. You can see if you have Truffle already installed by going to your computer and typing Truffle version. And if you do, you'll see some information here. I highly recommend using the same version of Truffle as me, which is version 5.1.39. So if you don't see anything there, you can install Truffle like this, npm install --g or global Truffle at version 5.1.39. The next dependency is the Ganache personal blockchain. So this is a development blockchain that we can download and install on our computer. So go ahead and head over to the Ganache website, download this and open it. And whenever you do, you'll have a local blockchain running. So you'll see you have 10 accounts here that are all credited with 100 fake Ether. Don't get excited. This Ether isn't actually worth anything in the real world, but this will give us some money to play with while we're building our bank. And it'll give us some accounts that we can use to connect to the network. Finally, we need to install the MetaMask extension for Google Chrome. So what is this? Well, most web browsers do not support a connection to the blockchain out of the box, so we need to install a special browser extension to do that. That's what MetaMask is. So go to the Google Chrome Web Store, search for MetaMask, install it. I've already got it installed, so you don't see an install button here, but you'll see an install button here. And whenever you've finished, you'll see a Fox icon here up in the top right-hand corner of your browser. So just walk through the setup steps on MetaMask whenever that's set up, and you'll have a wallet installed. So that will also allow you to hold cryptocurrency so that you can pay for transactions on the blockchain and also deposit money to the bank. Long story short is anytime you use the blockchain, you need a blockchain wallet. That's what MetaMask is. It's a browser extension. It lets you use blockchain-based applications, and you can install it like this. And so let's go ahead and start building out the project. So I'm going to go to github.com/dappuniversity/dbank. All right, I'll put a link to this down in the description below. And this is where we're going to get all the starter code for the project itself. So if you're brand new to coding, this is just a website where all the code for the project lives. You can download it like with Git, like I'm going to show you in my terminal here, or you can just download the code right here. If you do that, highly recommend going to the branches here, finding the starter kit branch, and downloading the code that way, because that's how we're going to get started. Okay. So if you're going to use the zip way, that's it. If you're going to use the Git way, then copy this URL here, go to your terminal and type in git clone, paste in the URL here. And actually we're going to do --branch starter kit. All right. And then actually let's take off the tree part here. Okay. So now we can enter into the newly created directory like this. Okay. And there we go. We're on the starter kit branch. So if you download it with a zip file, you'll just open it in your terminal manually, and you should see all the code here. So now we can do ls-l to ensure that we are in our project and that the files look the same. So it looks good to me. Okay. Now you can also do al, see the dot files and such. So now let's install all the packages with Node. So we're going to use npm. We'll say npm install, and we'll wait for that to finish. All right, so now that's finished. So let's go ahead and open up the project in our text editor. I'm personally using Sublime Text. You can use whatever text editor you like. And I'm going to open my project like this. So Subble dot is my shortcut that I have configured to open Sublime Text. So we can go take a look at what we have here. We have a Truffle project. So Truffle, again, is the framework for writing Ethereum smart contracts. We can also do a lot more like with Truffle. We can write the source code for the smart contracts in here. Go to sort of source contracts, and we can see a few files here already. So dbank.sol will be the smart contract where we actually create the bank. We've got a token inside of here, okay? We also can write tests for the smart contracts, which we have inside of here. So this test file, okay? We have a way to put the smart contracts on the blockchain, and we also have a front-end website. So you can see this source components here. This is where the front-end application will live. So let's take a look at everything that we're going to create. So if you think about this in terms of other application development, we have the back end, right? So the back end is going to be blockchain. So we're running a blockchain. So whenever you start Ganache, which we'll go ahead and do that now, make sure you have Ganache running. You should see your blockchain here running with 10 accounts, and they're all pre-funded with some Ether. So I've been using my Ganache already, so I've got a little bit less Ether in this account. That's okay. So I have a back end. This will be the blockchain, but all the code for the back end is going to be created with smart contracts. Okay, so we're going to write two different smart contracts in this tutorial. One for a cryptocurrency, so a token, and then one for the actual bank itself. So what this bank's going to let us do is deposit cryptocurrency, okay, and then earn a brand new token with interest, okay? And it's going to use the blockchain to calculate that all intelligently. So this will be the back end portion of the application. So now this back end is going to talk to a front end, all right? So this front end is going to be here. And this is going to be React.js. So React is a JavaScript framework for creating user interfaces. And we will have Web3.js that will turn our application into a blockchain application. So it'll talk to the blockchain, interact with our smart contracts, and let users interact with the front end part, okay? So we're gonna build this in a few phases. We're gonna start off with the back end part. So we're gonna code the smart contracts first, and then we'll move on to the front end. So what we're gonna do is create this token smart contract, this bank contract, and then we're gonna interact with those in the console, run the tests, and then create this front end application to talk to this. That'll be the last thing we do. So that being said, there's a lot to do here. And the reason we started with this starter kit branch is a lot of this stuff is kind of already set up. We're just going to fill in the gaps, okay? Because I'm trying to make this a quicker tutorial so that you can get this introduction faster, all right? So we're not going to code like every single tiny detail from scratch, step by step, like set up the project, create this file, create this file. All of the files are created for us. So we're going to hit the important parts so you can see like, how does Solidity work? How does a smart contract work? How do you interact with the blockchain? How do you create this behavior to make a decentralized bank? I want you to see the bigger picture important stuff, which you'll get without getting bogged down by all the details of creating every single file, et cetera, et cetera, et cetera, okay? So that's why if you open this project, you'll see this. You'll see we have some contracts in here already for the token, okay? And then also the bank as well. All right, so let's start off with the token contract, because like I said, there's two smart contracts in this tutorial, the token and then the bank itself. So let's explain what this contract does, and then we'll add some code to it to make it work, okay? So let's see here. In this scenario, how the bank will work is there will be two cryptocurrencies involved. So Ether, this is the native cryptocurrency of the Ethereum blockchain. So when you see this on Ganache, this person has like 100 ETH balance. This is the native cryptocurrency on Ethereum, all right, Ether. So what's going to happen is people are going to deposit Ether into this bank, okay? And then over time, they'll earn interest, and that will be paid in a brand new token like this, all right? So this brand new token is a cryptocurrency that we'll create, and it works very differently from Ethereum or Ether, okay? So like I said, this is Ether. This is the native cryptocurrency Ethereum blockchain. It's just built into the protocol. But what's cool about Ethereum is you can create your own cryptocurrency without creating a brand new blockchain with smart contracts, okay? So that's exactly what we're going to do in this tutorial. We're going to create a smart contract that powers a brand new cryptocurrency, this token right here, okay? And we're going to use something called an ERC20 token, which is just a description for how tokens should work on top of Ethereum. So you go to ethereum.org and look at the ERC20 token standard. This basically just says, if you want to create a cryptocurrency with a smart contract, it needs to have a certain set of behavior. So you can see that it specifies which functions that the smart contract should have. So it has to have a name, a symbol, has to have total supply. You have to be able to transfer tokens with the transfer function. You have to be able to, approve, look for events, all this kind of stuff, okay? So the whole idea is that if you create a smart contract, then it needs to be compatible with cryptocurrency exchanges, it needs to be compatible with wallets, it needs to be compatible with DeFi applications, and this standard specifies all that. As long as you satisfy this standard, then your token should work. So that being said, the ERC20 standard, if you're going to create a basic ERC20 token, then a lot of the behavior is a solved problem, okay? Because, there's no need to reinvent the wheel on how the transfer function works for ERC20 tokens because we know how it's supposed to work. There's no reason to reinvent the wheel on the approve function because we know how it's supposed to work. So for that reason, you can use a library to get a lot of the basic functionality of an ERC20 token off the shelf without having to code everything yourself, and then just customize it for your project, okay? That's what a lot of production cryptocurrencies do. So you can use that with the OpenZeppelin library, all right? And OpenZeppelin is just a open source library of community vetted contracts, cryptocurrencies, et cetera, okay? And they have an ERC20 contract that we can just pull into our project. So I've already added the OpenZeppelin package to the package.json file here. You can see OpenZeppelin contracts, okay? And inside this token file, we've already imported this OpenZeppelin contracts token ERC20 token into our project. And we're going to create an Ethereum smart contract with the Solidity programming language that is based upon the OpenZeppelin contract, okay? So it's pretty straightforward. It's pretty simple. Basically, this is how a Solidity file works. So if you go here, you see token.sol. So capital T token.sol is just how you create a new Solidity file. At the top, you have to specify the version of the Solidity programming language. So that's what you see here. Next, we import the library with this import statement. It's pretty straightforward. And then we declare the contract here. So contract keyword, so capital T token is ERC20. Okay, so that's that's how we inherit in smart contracts. We inherit from this ERC20. So that basically says we absorb all the behavior of this ERC20 token here in this current contract. So this is now a child of this parent. When we say token is ERC20, it's just the same here, all right? So then inside these curly braces, we add all the code, all right? So really, I could show you like this. If you're going to create a smart contract, this is all you need. And then you could say like, we could create a variable here, like string public name equals my token. Essentially what you're doing here is you're just creating a basic contract token, and then you put all the code inside of here, and then you create a variable with a string type, set it publicly visible so you can read it outside the smart contract, and you assign it name, and then you assign it here equals my token. All right. So that would be what a simple contract looks like. If you want to, inherit from the ERC20 standard, that you import it into the project like this, and then you say token is ERC20, and then now you add all this functionality below. So the first thing that we want to do with this is actually create a variable. So like I showed you a minute ago, you can do string public name. Well, we can do address. That's a data type. That's just an Ethereum address. So if you look at, Ganache, these are addresses. Okay, so you can do an address data type. So Solidity is a statically typed programming language. So you have to declare the type before you declare the variable. And so we say address minter. So minter is just the name of the variable. This is the person who's going to actually mint tokens. All right. And then we can say public minter. All right. And then whenever we deploy the contract, we want to say minter equals message sender. Okay. So message MSG stands for message. So this is a global variable inside of Ethereum or inside of Solidity, where we can get sender as the person who called this function. So whenever we deploy the contract, we run this constructor function. This is the function that gets called whenever this contract is created and put on the blockchain. And the minter is we're going to set this minter value to the person who deployed it right here. All right. So we call this public. You must call it public in order to deploy the contract. Payable, so we can send, funds. And then ERC20. So this is how we actually get this is how we run the constructor function of the ERC20 token that we inherit from. So we'll say name and then symbol. Okay, so let's just call this decentralized bank currency. And then decentralized bank currency, DCB for a symbol. Okay, so now let's wire up token minting. So let me explain what that is and why it's important. So whenever we issue tokens here in terms of interest paid, we're going to create the tokens on the fly. Okay, so basically, we're going to start from 0 and create tokens as people earn interest on their deposits in this bank. Okay, so essentially the token total supply is going to start from 0. And then whenever we create the token, we're going to give it to the bank so the bank controls it and it will issue brand new tokens. So let's look at what I mean by total supply. So if you go to Etherscan and you look at a cryptocurrency like Aave, so you just look for Etherscan, go to etherscan.io, search for Aave, and you'll probably see the Aave token come up. So you can see the max total supply here is 16 million Aave. So this basically means that 16 million Aave tokens will only ever exist. So Aave is an ERC20 token, and this is the total supply. So that's what I mean by total supply, is the total number of tokens. So our token is going to start with total supply of 0, and then we'll create new tokens as people earn interest in the bank. Okay, so that's going to happen with a minting function. So whenever tokens are created, a new function called mint will take place, and this will this was how new tokens will get created. Okay. So we can wire up the mint function like this. We use the mint function supplied by the ERC20 standard. So when we inherit this, there's underscore mint that already has this wired up. So this will just create tokens behind the scene. So if you want to dig into the code and read how that works, ERC20 sol, you can look at the mint function inside of here from the node modules. And you can see all the crazy complex logic that happens. If you want to, if you're a coder already, advanced coder, you can go read through all that step by step. But for now, just know that this is what creates tokens behind the scenes. So we wrap it in our own mint function. And one of the biggest reasons we want to do that is to ensure that the minter, this person right here, is the only person that can mint tokens. We don't want some random person being able to do that. So inside of Solidity, we can use a require function. So I would say require, and then whatever it is inside this function, if it evaluates to true, then it will allow this function to be called. If it evaluates to false, then this function will halt execution and it won't work. So basically, we want to say msg.sender, which we saw a minute ago, msg.sender, they must equal the minter. Okay. So if you're not the minter, then this function won't get called. And we can even give this an error message to say that, if they're not this, then, they don't have the minter role. We can display this error message on the screen, okay? So that's our mint function. And what we also want to do is be able to change who the minter is. Because whenever we deploy the contract, we will be the person who puts the contract on the blockchain, but we want to give basically whenever we create this token, we will create it. So we will be the minter. So we'll be the deployer. We'll be the account that deploys it. So inside of Ganache, this is us right here. Whenever we deploy the contract here in a minute, we'll be the minter. But eventually we want to give let the bank be the minter. So we need a function that lets us transfer that minter role. So I'll just go ahead and show you that here. Okay, so we'll create this function called pass minter role, and what we'll do is give it the address of the new minter, which will be the bank in this case. So this has some logic inside of it. It makes sure that we are the minter, just like we do here. Okay, and then we let the new minter be the dbank that we pass in here. This will be the second smart contract that we create. We haven't created it yet, and then we'll create a new. We'll emit an event. So Solidity lets you have events in your smart contracts, which we'll define like this. So event equals minter changed. So basically, what this does, smart contracts have events. So you can subscribe to these from a front-end application from the blockchain. Like if you go to Etherscan here and you look at events, let's see here. Let's go to the actual contract. So go to contract on a token, any token you want to. You should be able to see the events here. So you can see events right here. You can click on that and you can see all the events that have happened here. So you can see a transfer event. So this is part of the ERC20 standard. It requires that you do transfer events. You can see approval event, also part of the ERC20 standard. So we're gonna create our own event here called minter changed. Okay, so basically, like I said, smart contracts will have event logs, and we want to log every time a minter has changed, and that's exactly what this is for. We can also subscribe to this in our front-end application to get like a notification. You can configure this to be like a push notification on your phone or something like that if a particular event ever happened. So that's what events are generally used for, and that's why we have this minter changed event here. All right, so let's save this. And let's compile it. Let's go to our terminal here and do Truffle compile. All right, so it worked. So what did we just do? Well, we compiled the smart contract. So essentially what we did was we created a human readable copy here with this code. This is all human readable code in Solidity. And we took all that code and compiled it down into code that a computer understands. So specifically the Ethereum virtual machine or the EVM. So if you look at your project here, you go to, let's see here, source ABIs, and you'll see the ERC, let's see here, you'll see token.json here. So what this file does is it does a couple things. It creates an ABI, which is just a JavaScript or a JSON representation of your smart contract. So it describes like the type of functions that are inside of their basic interface. That's what ABI stands for, Abstract Binary Interface. And you can also see this bytecode here. So this is the bytecode that actually gets put on the Ethereum virtual machine that Ethereum, a computer, understands. So whereas a human can read and change this code, a computer needs to understand this code. All right. So you'll see more about this later, how we use this when we create client-side applications. We'll revisit ABIs. But now what I want to do is actually put this contract on a blockchain. So how do we do that? Well, we can go to our top level here and go to migrations and look at this deploy script. So inside of here, we can actually write a migration script that puts the smart contract on the blockchain. So essentially what a migration does is it moves the smart contract from our computer to a blockchain. It migrates it from one place to another. You could also think about it like migrating the blockchain's state from one state to another because it changes the blockchain whenever you put a smart contract on there. Either way you want to think about it's fine, but you need a migration file to do that. So this is standard practice for Truffle, basically to create a script inside this migrations directory. When you have these numbered scripts here, so Truffle knows which order to run them in. So number 1, number 2. Okay, so number 2 is the one that we've created. Number 1's initial migration that always exists. Number 2 is one we created to deploy the contracts. So at the top, we import the smart contracts here in JavaScript. So these are called artifacts. So you see this source ABIs here. These are technically the artifact files. This would probably be better named artifacts, but that's okay. Like these artifact files contain the ABIs. But anyways, Truffle uses this idea of artifacts to help create JavaScript versions of the contracts inside the framework. So we can import the token contract we just created like this, just const token. So this is all in JavaScript here if you're brand new. We were writing Solidity over here. Now we're writing JavaScript. That's the whole idea. You write the smart contracts in Solidity. You write pretty much everything else in JavaScript. So we import a JavaScript version of the token like this, artifacts require token. We assign it to a new variable with const token like this, all right? And we'll deploy the token. So we'll just go in here, deploy it like this. We use the Truffle deployer. We just say await deployer dot deploy, and we pass in this token that we imported here. And then what we can do, well, yeah, let's just do that for now, actually. Let's just do a really simple migration. We'll fill out the rest of this later whenever we create the bank itself. These are more to-do items, but first I just want to get it on the blockchain, show you how it works, show you how to deploy contracts so we can interact with it in the console. So you can go to your terminal and just type truffle migrate. So migrations run the migration files. So whatever you tell Truffle to do inside of here, it will do behind the scenes. And you can see here, it worked. So you can see the steps. It's compiling the contracts, so everything's already up to date. We already did that step. Starts the migrations. It runs the first one, initial migrations, which we didn't touch. And then number 2, deploy.js. So it worked. You can see the transaction hash here. Okay, you can see the account that deployed it, the balance of the account, the gas used, the gas price, and the total cost of deployment here. All right. And then, yeah, there you go, final cost. So now we can actually interact with the token in the console like this, say Truffle console. So this will open a JavaScript runtime environment where we can execute commands and interact with the blockchain, interact with the token that we just deployed. So what I'm going to do is say const token equals await token.deployed. All right. So this confuses a lot of people. Whenever we get here, they see this undefined. That's just the logged value. That's not actually the value of the token itself. You can do token, and you can see the JavaScript version of the token here. So what does this mean? Const token equals await token.deployed. Well, again, this is JavaScript. So we say const token, we create a variable here, and then we assign it to the token that gets fetched from the blockchain. So what is this await keyword? Well, some function calls in JavaScript are asynchronous, which basically means the function doesn't actually return the value by default. So if we said like const token equals token.deployed, this wouldn't work because this is an asynchronous function. So blockchains are slow, and by nature, we want to interact with them in an asynchronous manner, which basically means we wouldn't always assign this to a variable. We could just call token.deployed, wait for it to load up the token. And because it's slow, we can handle the return value of an async function in a variety of ways. So you can look this up more on the internet if you want to read about this, but what we'll do mostly in this tutorial is use the async await pattern. So we'll just say await. When we put this keyword in front of it, we're basically just saying we want to wait for this function to finish. And whenever it does, we want to get the return value and assign it to a variable. Okay, so if you want to read more about how promises work in JavaScript, you can just Google that. But that's basically what we're doing here. So anyways, we already did that. You can't assign a const twice, so that's why it's blowing up here. But anyways, so we can see token.address. So here's the address of the deployed smart contract. So just like any other contract on Etherscan, they have addresses. We have an address here. You can see the token.name. Okay, so the decentralized bank currency, token.symbol. All right, so just like we coded inside of here. We can see token.total supply. All right, is 0. All right, so now I want to show you how the mint function works, because basically we want to be able to create tokens on the fly. So inside of here, well, first let's look at our accounts. So account, We can get accounts with Web3 like this. So Web3 is a library that lets us interact with the Ethereum blockchain. We're going to see more about Web3 later on in the tutorial when we wire up the client-side application. But basically, you can interact with Ethereum through this JavaScript library called Web3. So we can actually get all the accounts that are in our wallet pretty easily and then inspect their balances like, hey, how much Ether do I have, et cetera, et cetera. So we can open Ganache. These are all our accounts in our wallet. So we can get the accounts like this, Web3, ETH, get accounts. Okay, so these are all the accounts in our wallet. So we can say accounts equals this. All right, and then we can say, so const accounts equals Web3 ETH get accounts. These are all the accounts in Ganache. So now we can say account equals accounts 0. So what does that mean? Well, accounts is an array. So this thing right here is an array. Basically, anything inside these curly brackets here, it's just like a list of information, basically a sorted list. And these are strings. Okay, so strings are just like, characters inside these quotation marks. And then you see these commas, right? So basically, it's a list separated by commas, and everything inside of here is a string. So it's just like a string of characters that's contained inside of a quotation mark here. Okay. So for brand new people, that's what an array is. These are strings inside the array. That's what it looks like. So we can get the first item out of here by doing accounts and then giving a bracket. That's how you read information out of array. You say, if I want the first thing in the array, I use this bracket and then I give it the index. So arrays are 0-based index, which basically means the first item is 0, the second item is 1, the third item is 4. Well, I think I kind of wrong. First item is 0, second item is 1, the third item is 2. Sorry. Anyways, so that's why you see account equals accounts, and then you read 0 out of here. It's undefined. That's okay. That's because it's logged value, and you just say account. Well, actually, hold on a second. So that didn't work either. Accounts. So let me try this again. Const. Let's say. Let's try this again. Accounts equals. I think I have to wait. Yeah. Sorry, everybody. And get accounts. Okay, yeah, there you go. So here's the first account. This is the exact same account here in Ganache. So what we want to do is we can read information about this account. Like we can get the account balance. We can see how much Ether it has. So we say account. We can do Web3 ETH get balance. We can say account, and you'll see this huge crazy number. Okay, let's just do balance. Okay, so BAL is just for balance. You'll see this big, long, crazy number, which doesn't make any sense because you see 98.89 here. Well, that's because this isn't actually the Ether value. It's the Wei value. So what do I mean by that? Well, Wei is basically like a penny for Ethereum. So you can look at like Ether versus Wei. So the reason it's, so I'm trying to think the best way to explain this. Wei is sort of like a penny. So if you look at US dollar, for example, $1 has 2 decimal places after it. So $1, 1.00. Inside of Solidity and Ethereum, we don't use decimal places at the smart contract level or the Ethereum virtual machine level. We don't use decimal places. We only use, integers basically. So you would write $1 at the Ethereum level like this. You would always express $1 as 100 pennies. You'd never express it as you'd never express it as $1 with decimal places after it because we don't use decimals. So same thing with Ether. Basically, Ether has, smaller resolution as well. So basically, if you were to write Ether like US dollars, it'd be 1 followed by 18 decimal places. So like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So if you were to write Ether without decimal places, you would express it in Wei. All right, so Wei would be 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 decimal places after the 0. This is how you express Ether at the smart contract level with 0 decimals. Okay, use this big number like this. So that's why you see this big long number. You see 98.89 Ether here, but it's really this much Wei. All right, so that's really important to know. The same is true for tokens, many tokens. So tokens will have decimal places. So you'll see this like ERC20 token decimals. You'll see 18 decimal places. A lot of times that means there's 18 zeros after the decimal. That's just really standard because Ether has 18 decimals after the 0, and they make the tokens work like Ether. So that's why the balance looks like this here. And for the same reason, one reason I want to show you this first is we're gonna test out this mint function that we created in the smart contract. So inside of here, we're gonna call this mint function. We're gonna mint tokens for our account. So first of all, let's just check the balance of this account. Show you how the token works. Again, the ERC20 standard has a balance of function. So let's just zoom in on this. You know, it's got a name, symbol, decimals, which we've seen. Let's actually show our decimals in our contract here. So token.decimals. And let's actually do it like this. So let's say await decimals equals await token.decimals. All right, and then decimals to string. All right, so it's 18. So we have 18 decimals after the 0 for this token, just like Ether. All right. So the reason I want to do this is to now look at the balance of function. This will basically tell us how many tokens this person has. So we can pass in the owner address, which we'll do for this account here. And it should return 0 because no tokens have been created yet. Okay, so we can say balance equals await token balance of account. Oops. So balance is 0. So let's mint tokens. So one thing I want to show you actually before we do that is this account here. Let's do account balance here, or Ether balance. Okay, so Ether balance. So what we can do is actually convert this to Ether. I meant to show this a second ago, but I forgot. So we can do Web3 utils. So Web3 is built in here. Web3 utils from Wei, and then pass in the Ether balance. Oops, sorry. And there we go. We convert it straight to Ether like this. And now you see the Wei balance to Ether. We can also do the reverse. Web3 utils to Wei. And then say, you know, 98.89. And convert it to Wei like that. Okay, so this is a nice helper that we can do. So the reason I say that is because I want to mint tokens. So I want to do token mint, and then I want to do it for the account. And then I want to do amount. I want to say Web3 utils to Wei, because remember at the smart contract level, we don't do decimals. We pass in tokens without decimals. I'm going to mint this person 100 tokens. All right, 100 to Wei. And then there we go. So minting our self tokens. All right, and it worked. So now we can say token, token balance equals await token.balance of account. Token balance is now this big number. So we can say token balance to string, convert it to a string away from a big number. All right. And then we can convert it to the actual token amount, not the way amount like this. Let's see, Web3 utils from way, token balance. There we go. Boom, 100 tokens. And we can also see token total supply like this. And then do Web3 utils from way, total supply. And there we go. There's 100 tokens total. So you have just created your first smart contract, put it on a blockchain, opened a console, and actually interact with Ethereum. So congratulations. This is the first milestone where we set everything up. Now we want to go ahead and start creating that second smart contract, the actual bank itself. So now let's get into coding the actual bank contract itself. So go to source contracts. I'll collapse some of this so you can see it. So go to source contracts and then dbank.sol. So inside of here, we have some placeholders, okay? We have a deposit withdrawal function. That's essentially what this contract's going to do. It's going to let us deposit funds into there, and then we can earn interest on it, and we will get this interest back whenever we withdraw it, okay? So let's go ahead and well, let's take a look here first, actually. Here's our diagram. We take Ether, we deposit into the bank with the deposit function, we wait, and then we withdraw the tokens like this. And the bank actually mints the tokens for us to pay that interest out, whatever we call this withdrawal function. So we're gonna code all this out step by step. So let's go ahead and get started. So we can go inside of here, and the first thing we want to do is assign the token itself. So remember, whenever we deploy this, we want the bank to control the token because that's who's going to mint the tokens for the depositors. We just minted tokens in the console ourselves because we, the deployer, still had control of the token in that sense, or at that time. But what we want to do is actually transfer the ownership of the token to the bank itself and let them mint the tokens. So the first thing we want to do inside of here is modify the smart contract to control the token. So first, it needs to know about the token. So we've imported the token here. All right, import token.sol, which we created here. All right. And then now we change the constructor function. This is, again, the function that's run whenever the contract is deployed to the network, this special constructor keyword. And we say token, and we pass in the address of the token. All right, so basically this will accept the address of the token, its location on the network. We saw the address of the token in the console. And we want to store this token inside the smart contract with a variable, a state variable like this. So token private token. This is a state variable. Its value is actually written to the blockchain. But we use a local variable here, token, and we basically can assign it inside this constructor function like this. Okay, so we just say constructor token underscore token equals token, which is this token. All right, so the whole idea is we just want to assign the contract. This contract needs to be aware of where the token is. All right, so we just save that. Now let's modify our migration file. So let's go here to the migrations directory, go to deploy, and then we'll fill in some more information here. I'm just gonna paste these in here and we'll talk through all the steps. So in our initial migration, all we did was deploy the token to the network here. So deployer, deploy token, but then we wanna execute several other steps after that, right? So we want to fetch the token. Token equals await token deployed. We saw that in the console. It's the exact same code. We assign it to a variable. Then next we deploy the bank to the network, just like we deployed the token here, okay? So we do deployer, deploy bank, but then we pass in the actual token address. So that's what you see here for the bank. It needs to understand the address of the token in order to keep track of it. So that's what we do here. All right, and then we assign this to a variable, just like we did. So token.deployed, so dbank.deployed, assigned to a variable. And then the last thing we want to do, which is the most important step, well, not most important, but a critical step, is pass minter role to the bank address. Because again, we want to take the token and instead of the minter controlling it, we want the bank to control it. So we created that pass minter role function here inside the token that transfers the ownership or the minting to a different account. And so that's what we do right here. We call that function, we pass in the dbank address, and by default, it's going to be from the account who deployed the contract. The account who deployed the contract, which is that first account in Ganache right here. Okay. So we'll save that. And that's the first thing. Basically, we just keep track of the token inside the smart contract, and then we update the migration script to deploy the bank on the network and then transfer the minting to the token itself so that it can pay out the interest to the depositors. So let's code out this contract. Again, we've got the basic setup here. We have the functions coded out, but we want to fill them in. We have the instructions here. But there's two things we need to write. Okay, so the code for the actual smart contract itself, but also tests for the smart contract. So what is that? Well, basically, you can write code that checks to make sure that your code actually works. That's what a test is. So tests are important in many aspects of software development. They're particularly important for smart contract development because smart contracts don't change when you put them on the blockchain. All you can really do is like deploy a new copy of the smart contract if you want to change the code itself. So you really want to make sure that the smart contract works before you put it on the blockchain. Now, if you're just developing an application with Ganache, you can put new copies on it, all that kind of stuff all day. It's okay. But whenever you go to like make your application work for real, you want to write tests and make sure the code works the way you want it to before you go live to a blockchain, I'll put it that way. So that being said, you can write tests in JavaScript. So you can look inside this test directory and you can see the tests already written here. So I don't want this to turn into an 8-hour tutorial. So we're not going to write the tests out step by step. We're actually just going to leave them in here inside the starter kit. But these are the tests that actually check for the behavior of the smart contract. And they're going to fail right now because we don't have the code written. But what's cool is we can actually write the code to make these tests pass, and we'll see what the behavior of the contract actually is supposed to be like whenever we do the tests. So I'll talk about the tests here. I'll go through the testing framework, show you how it works. So this is a Mocha testing framework in the Chai assertion library. So Mocha comes bundled with Truffle, and then Chai gives us these assertion matchers, like so expect, all right, all that kind of stuff. So let's just comment out some of this stuff and make it pass, okay? Well, some of it will work. Some of it will work right now already. So basically, we have the token test inside of here already, and we see the exact same setups. So basically, we have this contract dbank, and we get the accounts, so the deployer and then the user, two different accounts on Ganache. So this account and then this account, and then we see, we basically do like we do in the migration. We get a token, we get the bank, and then we pass the minter role to the bank, just like we did in the token setup, or just like we did in the migration setup. And then we write some tests. We say, testing token contract, and then we just check to see that the token exists. It has a name. All right, just like we did in the console. So you write code that says like it reads like English. So it, checking token name, which you can write that differently. Say like it has a name or something like that. It, has a symbol or something like that. And each inside of those, you say expect, and then we just like get the symbol and we say expect it to be equal, DCB, or expect it to be equal decentralized bank currency. Expect the supply to equal 0. Expect the minter role to belong to the bank. All right. Same thing here. We can also check for failing transactions. So we shouldn't be able to pass the minter role anymore once we've done it. So we can say it's ejected with EVM revert, which is a shortcut that we've saved from here. et cetera, et cetera. All right. So let's go ahead and run those tests. We'll say, let's exit the console here, .exit, and then say Truffle test. Now we're back into our terminal, not the Truffle console anymore. So let's combine the contracts. And then boom. Okay. So looks like it said expect DCB, got DBC. All right, so I'll change that. I actually wrote the code wrong. So let's go to token, DBC. Sorry if you saw that earlier. So let's make the test pass. So that's the whole idea. The test fails. We change the code to make the code work, and then the test pass, okay? All right, so now the token works exactly like we want it to. It has a name, has a symbol, has a total supply, has the mentor role to the bank, all that kind of stuff. So boom, you can read through this test if you want to. Now let's get into coding the bank itself. So we're going to describe testing deposits. So the whole idea is that you can deposit Ether into the bank. So what it's going to do is check the balance. It's going to call this deposit function. And we're going to deposit 0.01 ETH from this user, so this second account in the list. And then basically whenever that happens, it should increase the bank balance. So if you go here, again, this user is going to have an Ether balance. Let's say their Ether balance before the deposit is 100 Ether. Okay, they're going to deposit, 0.01 Ether into the bank. Oops, sorry, 0.01, I believe is the correct amount. Yeah, 0.01 Ether into the bank. Okay, and then their balance should go down to after they do that, they should be at 99.99 Ether, plus a little bit less because they have to pay a gas fee. And then so that should be their balance in the bank, and then their Ether balance should be less than this, slightly less than this because they pay a gas fee. Let's explain that. Whenever you create transactions on the Ethereum network, you have to pay gas fees to prevent spam on the network, to help maintain the security of the blockchain. So basically, if I send cryptocurrency around from one account to another, then I pay a gas fee to do that. If I put a smart contract on the network, I'm creating a new transaction, I have to pay to do that. If I'm depositing funds into this dbank here contract, that's a new transaction, so I have to pay to do that. So you can think about it this way. Anytime you write new information to the blockchain, you have to pay. But anytime you read information from the blockchain, that's totally free. Okay, so reads are free, writes cost gas. So let's go back here and look. So it should increase the balance to this. All right, which we can see here. This is 0.01 ETH. This is also 0.01 ETH. And then, so the deposit time should be about 0. We'll look at that in a second. Deposit status should equal true. So they are deposited. And then, yeah, so we'll start off with that. So we'll run the test. All right, so it's not working. So you see all kinds of failures here. That's okay. We're gonna make them pass. So let's start off with this. The balance should increase. So go back to our bank. Excuse me. And we start off with this. So we want to go with the core functionality of checking that the deposit exists. So we want to track a way to store the Ether balance. So we're going to use something called a mapping. Okay. So mapping is pretty easy. We add something looks like this. We say mapping and we say public Ether balance up. So mapping is just a key value pair storage mechanism for Solidity. So think about like a dictionary where you have a word and then a definition. So you have a key and a value in a very similar way with a mapping. This is a way that you can store. You can use a blockchain like a database. This could be a number. It could be an ID. Like if you want book number 1, you could have a uint here and then return, a book. So in this case, though, we're just going to have an address is going to be the key. So the person's address who's depositing, and then the uint is going to be the amount of ether or cryptocurrency in the way value that they've deposited. So it'd be like a dictionary. So we'll say like, here's this person's address. How much cryptocurrency do they have deposited into the bank? That's what this mapping's for. It's going to be public, so we can read that information outside the smart contract in the console in an application, and we'll call it ether balance of. Okay, that's the variable name for this mapping. So inside this function, we can write new information to this mapping like this. We say ether balance of, and then the address is going to be msg.sender, message.sender. Okay, this is the person who's calling the function again. So basically we're going to say the address of this person, message sender. And then the balance will be ether balance. So we could just say like 1. All right, so anytime they deposit, so that's not a good example. Message.value. So we could basically just say, whenever they deposit, we take their message, they take their account or take their address, use it as the key, and the amount of cryptocurrency they're getting sent in is message value. So when they send ether in the transaction, this is the amount of ether that they're sending. So message value, this is the person who's sending it. Message sender, message value is the ether amount. So we could just assign it to mapping like that. Now we want to take it one step further. We want them to be able to call this function multiple times. So we can just add that value to the last value. So basically just copy this. We assign values to a mapping like this, but we can also read values out of we can read the value out of the mapping like this and say ether balance of message.sender plus message value. So we're reading it out here, we're adding more to it, and then we're assigning it back here. Okay. So that's what we do whenever we deposit. That's the core functionality really of the deposit. Okay. So let's just try that. And let's try to run the test and see if a new test passes. I think the first test should pass. I think this balance should pass. Let's see here. Yep, it works. So we got a brand new test to pass. So the balance should increase. Let's take out token, go to the test, and see. Yeah. So the balance does increase. That worked perfectly. So now we should do the deposit time should be greater than 0. So what's the deposit time for? Well, basically, the deposit time is so we can calculate the interest earned. So whenever you deposit money into a bank, think about your APY or your annual percentage yield, where basically they determine how much money that you'll earn on your deposit over a year. So if you have 1% APY, you'll take 1% of your funds deposited and give you that amount in interest, okay? So we can do the same kind of thing inside of our bank. So we're going to do that inside of our account. So how do you do it inside of a bank? Well, how do you do it inside of a blockchain-based bank? How do you determine the time? Well, you can do it from the number of blocks that have passed, okay? So there's you can always tell the time on the blockchain from the blocks. So if you go to Etherscan, you look at these latest blocks, they all have a number, okay? Block number 11882876, and then you see the one before that. All right, number of that, number of that, number of that. So Ethereum has a block time, so we can predictably say like what block, like we can predict like when certain blocks going to be mined on the blockchain, roughly speaking. So we can use the blocks that have passed in time to calculate the interest. So that's why we want to, and so we're gonna keep track of that. You'll see, it'll be clear in a second. But we want to track basically the deposit start. We want to get the timestamp of the current block so we can make the calculation on the actual interest that they're getting paid. Okay. So we'll create a new mapping. So ether balance of, we'll say deposit start. So essentially we want to basically, so I'm trying to think of the best way to explain this. Basically, we want to keep track of the timestamp of when their deposit is with the block on the blockchain. So we'll do it like this. We'll update that value like this. All right. Say deposit start for message sender equals deposit start plus the block timestamp. Okay. And then save that. Go back to our terminal. Run the test. So more tests are passing. All right, so deposit time should be greater than 0. That works. So now we want to check the next test, which is deposit status should equal true. So now we want to keep track that they are actually depositing. So we can go inside the test and do that, or sorry, inside the smart contract and do that. We want to set the status to true. So we want to create a new mapping for that. So basically, we'll just create a new mapping like this. So is deposited. And then we'll add it here. Okay. And so now we can run that test again. And there you go. The deposit status is equal to true. So now let's finish off a few more things. Let's create an event for deposit. So again, we use events to track that certain activities happen on the blockchain. So we want to trigger a deposit event. We create it like this. We give it the user, the ether amount, and the time start. And then we can emit it inside the smart contract like this. So emit deposit, message sender, message value, block timestamp. All right. And then the last thing we want to do is fix this test. So depositing should be rejected under certain conditions. So I showed you how require works in that previous section, but we're going to add some new requirements here. So we want to make sure that the deposit is not already active. So if they're already deposited, we don't want them to call this function again. So they got to withdraw before they increase their deposit if they want to, just for this particular example, so that it can support borrowing and lending. All right. And then, and also make it easy. So require message value equals greater than this. So we want deposit to be at least 0.01 ETH. Okay. So now let's run the test. And they should all pass because we have this failure case here. We try to deposit with a value less than 0.01 ETH, and that should not work. So for homework, you could try to call it twice and also get this failure. There we go. They all pass. Awesome. So again, you could write a new test here to make sure that you can't deposit when you're already depositing and check for this failure right here. Okay. So now we're officially done with the first part of the smart contract. We're getting really close. we're going to process the withdrawals. So let's do this, okay? Let's just talk about what needs to happen whenever they withdraw. This is going to get kind of complicated, but I want to show you. So whenever we withdraw from the bank, let's just do a no drawing here. All right. So the flow here is the user deposits funds into the bank and then they wait, let's just say for a while. Whenever they withdraw, they're going to get two different currencies back. They're going to get their principal back, which is the Ether, but then they're also going to get this token back based on the interest. So let's say they're earning, 10% APY. Well, we're going to take 10% over a year and divide it up by the actual amount of time that they deposited, and then pay them that amount with a second currency in tokens. So for simple math, if they deposit 1 Ether, and then their deposit for, 1 day, then basically we'd take like 10% and then divide it by 365. And it would be this much. All right. So it would be a pretty small amount. But so that we're going to do some math to do that. And we determine the amount of time that they deposited, again, from these blocks on the blockchain and how many blocks have passed. Okay. So that's why we track this block timestamp, all right, to see when it happened. So, yeah. So it's kind of complicated, but we're going to walk through all the basics of how this works. So let's start off with the core functionality, which is just withdrawing the Ether itself. Okay. So if you go to the test and then you uncomment this out. So just drag withdrawals. We've got some setup here where basically they're just basically depositing values in here. We just wait for a little bit and then we withdraw. So it does a deposit, it waits for some actual amount of time. So you can see what the wait function does here. Oh, sorry, let's go to the top. You can look at this helpers file. And you see this wait, what it does is it just waits a few seconds basically. And then it does a couple things. It checks that the Ether balance, it checks that the balances are correct. So it takes the balance out of the bank and gives it to the user. And then it checks that the user should get their Ether back. And then the user should get the interest paid. And then the depositor data should be reset. Okay. So we're going to test these things one at a time. We're just going to test first that the Ether should come back. All right. So I'll show you how to do that. So you go to dbank, and then basically whenever we withdraw, send Ether to the user, we use the transfer function. So message sender, the person who is withdrawing the money, we're going to send Ether to them with this function called transfer. So this is just a function of Solidity that sends the Ether around. And how much do we want to send them? Well, we read their Ether balance. So Ether balance of message sender. Okay. And we send that ETH back to the user. So Ether balance of message sender, we send it back. So that's the first step to sending this Ether whenever we withdraw from the bank. Okay. And then after we do that, of course, we reset their data. We say Ether balance of message sender is now 0 because we just took it out. So that's the first thing. So let's run the test and see if that passes. All right, so it works. They receive their Ether back. So next, let's reset all the rest of the deposit data. Well, before we do that, actually, let's now look at the interest. So in order to calculate the interest, basically, let's do this. We first check the user's hold time or HODL time, like this. So deposit time equals block timestamp minus the deposit start. So basically, that's what I was saying. We determine the amount of time by looking at the blocks. We look at their timestamp. So their timestamp comes back in seconds. Okay. So the seconds are based on epoch time. So you can look at this. So this epoch time right here. Let me just put it up here. So if you want to take the current epoch time of recording this video is this. So this is just the number of seconds that have passed since like 1969, I think is the day. But you can always express time in seconds since that event as this. This is the current epoch time. So block timestamps have this baked in. So you do time in seconds inside Solidity. So that's why we stored the block timestamp here. Deposit start was at this time, so block timestamp. So now we just say how many seconds have they been depositing for. Take the block timestamp and subtract the start time, the current block timestamp, and subtract the start time. Okay. And then so we can calculate the interest like this. We can take, we basically take an annual interest rate and we calculate how much interest that person would earn per second. So for example, if the interest 10% APY, or a 10%, let's just say 10% per second or something like that, then this is how you do it. Okay. You would divide it and find the interest per second. All right. And then you get the actual interest, and we give them tokens based on that actual interest like this. We take the token, and remember the bank now controls the token. So the bank just creates the tokens from scratch, and it sends them to the user with that mint function that we played around with in the console earlier. So basically just say token.mint, message sender, interest, all right? And then we want to reset the deposit data, all right? So basically, we got the Ether balance already, but we want to reset the deposit like this. So deposit start is now 0, okay, because they've now withdrawn everything. Ether balance is now 0 because they've withdrawn everything. So it is deposited. They are no longer deposited. And the last thing we want to do is basically make sure that they have deposited, because if they haven't, we don't want them to withdraw. And we're going to cache their balance at the top of this, so user balance. Okay. And then we can say we want to emit an event at the bottom, so withdraw event like this. So I'm moving kind of fast here, but this is the tail end here. So withdraw message sender, just like we did a deposit event here. All right, you can pause this and take a look. But the last thing we need to do is actually create this withdrawal event right here. And then we just created it here. It's basically the same thing as the deposit event, just named differently. And we do a new time and we log the interest. And let's see here. The last thing we want to do is probably change this user balance. Probably just, update that code to use the user balance, so we're using the same variable twice. All right, so let's run the test now. Let's actually uncomment all the tests, and it should all pass. It's waiting. Every time the test run, it waits 2 seconds. All right, there we go. It all passes. So that is the complete code for the bank and the token. So the last thing we want to do is deploy this to the blockchain itself so that we can create the front-end application. So we can do that like this. Say truffle migrate -- reset. Okay. So the -- reset, what it does is it takes a new copy of the smart contract and puts it on the blockchain. So this is, like I said, the smart contract code can't change. So the best thing you can do is just deploy a new copy of it, put it on the blockchain, and that's exactly what we've done. So now let's go ahead and move on to creating the client-side website for the bank and interacting with it. All right, now let's start coding out the client-side portion of the project. So what we're going to do now is create a website that talks directly to our blockchain. Okay. And it's going to interact with the smart contract that we created. Okay. So we're going to talk directly to the smart contract for the bank. We can deposit Ether into this through this website. It's going to be a user interface that will serve as the front end part of our project. Okay. So this is front end, and this entire thing here is the back end. All right. So we finished the back end part effectively. Now we want to create the front end so people can interact with it. So if you go to our project here, let's just, so you can see our smart contracts, everything we've done so far. You'll want to go to source, components, and you can look at this app.js file. So I'm going to minimize everything else for now. All right, so source, components, app.js. And here you can see some code already wired up for you, and we're going to fill this out. So what is this? Well, this is a React component. So we're going to use React.js to create the client-side application in this tutorial. So React is a JavaScript library for building user interfaces. So basically, it lets you it lets you write JavaScript interfaces with less code. You get a lot of stuff for free. You'll see how React works in this video. You don't have to be an experienced coder. You don't have to, be an advanced React user in order to follow along with this. You'll get the basics as we go. The important things to understand is React uses components to organize the code. Our component looks like this. You see this class, component name extends React component. And then you put HTML and JavaScript mixed in together inside these components. So HTML is just like the HTML markup language that you use for a web page, but then you have this other code, which is JavaScript inside of here. And then you can use these curly braces to put JavaScript inside the HTML code. So it's like, double nesting. So like HTML inside JavaScript and then JavaScript inside HTML. Okay. So if you go to our app, you can see class app extends components. All right. And then we put all the code for the component inside these curly braces, a lot like our smart contract where we put all the code inside those curly braces. So we have a bunch of important things imported at the top. We don't have to worry about that too much. We'll just see it all filled in this project, okay? So other things to know about React is it uses components to manage all the behavior and all the display logic and all that kind of stuff for the app. It also uses something called the state object. So we'll see the state object play out in this tutorial. So think about state like what should be shown on page. Sometimes state's hard to describe. Let's just use this example here. We have a to-do list. So what needs to be done? You add items to the to-do list. Item 1, item 2. Okay. So how does this application know how many items are on this to-do list, right? How do we add new items? With something called a state object. So the fact that this to-do list has 2 items on it is a description of the website's state and also the state of this particular component that governs this to-do list, okay? So that's what it means by state. So you manage it with the React state object. You can see it here. So they have this pattern. They tell us how to do it. So constructor props, this state equals this big object here. and we just put in the items for the to-do list and the text, okay? So you'll see that inside of our app here, constructor, super props, this state, and then we have some placeholders that we're gonna fill in. So we're gonna use stake kind of like a front-end database for this application. So like we're gonna load in our account, store it to the state, so the account that we're connected to the blockchain with. We're gonna store the token smart contract to the state. We're gonna store the bank smart contract to the state, the balance, the bank address, all that kind of stuff, okay? We're gonna use it kind of like a front-end database. So now, excuse me, that's an introduction to React. So we're also, I don't want to spend a bunch of time writing CSS or styling this particular application, so we're gonna use Bootstrap. So this is a framework for building websites and user interfaces that look nice without writing a bunch of extra code, okay? So we're gonna use the React version of Bootstrap, and you can see that inside this package.json here. So React Bootstrap, right? So like if you go to this app, you'll see we're gonna import some tabs from React Bootstrap. We're gonna use some components from React Bootstrap. We'll get a bunch of freestyle. You'll see all that as we go along, okay? And then the last thing I wanna mention is Web3.js. So let me just pull that up. So Web3.js is a JavaScript library that lets us talk to Ethereum. We saw Web3 in the console, and we did like Web3, utils from way, Web3, get balance, all that kind of stuff. So Web3 is basically going to turn our application into a blockchain application. All right, it's going to take all this JavaScript code and connect it to the blockchain itself. So if we don't have Web3, then we don't have a blockchain application. The other thing we need to do is, I know there's a lot of setup here, but I want to get through that so we can actually start coding, is to basically connect our web browser to the blockchain itself. So we do that with MetaMask. So open up MetaMask and then go to import account, all right? And then it'll ask you for a private key. So what we want to do is take our account from Ganache here, click on show keys, copy this. Of course, never use this private key for real, because everyone who's watched this video could steal your money. So copy that private key, put it in here, click import, and I've already done it. So, it won't do it again. But anyways, I've changed to this account. You should see your account balance here, which is the same as Ganache, right? The last thing you want to do is connect to a Ganache network. So you won't necessarily see it here. You can do custom RPC, and then you can call it Ganache. You could just say, Ganache. You can say HTTP localhost port 7545. You can go here and verify that. You could just copy it, RPC server, http://127.0.0.0.1:7545. That's just localhost. You can paste that in. All right. Chain ID. You can look at that from Ganache here as well. Say ETH. Okay. So this already exists, so I can't do it again. But you can name it Ganache and just make sure you connect to that network before we get started. All right. So now we have done a lot of the prerequisites. Let's go ahead and boot up our web server. I'm going to open a new tab here and say npm run start. This will start your web server. If you ever need to stop your web server, just hit Control-C. All right, and that will stop it. So now this looks like it's got an error. That's okay. We can fix this. So the error went away. But now you should see a blank canvas here. All right. We can see a nav bar at the top. Here's our dbank. Okay. So we're making some good progress here. We've actually got some code on the page. Now let's actually wire some of this up so that we can make it work. So the first thing I want to do is just connect this application to the blockchain. So we're going to do that with the Web3 library, like I said. And it's pretty easy to do it. So we'll start with this. Basically, we're going to get a copy of Web3 that MetaMask injects. So MetaMask basically puts a variable in our browser that we can fetch out. And it's like a handshake, basically. MetaMask gives us something. Our app can take it and turn it into a blockchain connection. So we just do it like this. It's pretty easy. We say const web3 equals new web3 window.ethereum. So window.ethereum is what MetaMask gives us. And then we can turn that into a new web3 connection like this, which we import here from the top of our file. And we turn it to a variable called lowercase web3. Pretty simple. All right. Now, we want to make sure that the user is actually connected to MetaMask. So we can do this. Basically, we can wrap a conditional inside of here if type of window.ethereum is undefined. Or if it's not undefined, then we can, do this connection. And if not, then we want to say, hey, please install MetaMask. Okay. So if they access this on a different browser, doesn't have MetaMask installed, then we want to show that error message. So I can open like Safari, for example. I don't have MetaMask installed on Safari. And you can see this error here. So please install MetaMask. That's what we want a user to see. You can customize this error message and say, hey, you're visiting a blockchain website. You need to have a special browser extension, blah, 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 blah. Have some special instructions, be much more helpful, link off to the website, tell them how to do it, maybe show them a video or something. But here's the basics. Like you could just show this alert that says, please install MetaMask, okay? So now, excuse me. The next thing we want to do is actually fetch some information from our blockchain connection. So we have already checked to see if MetaMask exists. Let's actually just get the network ID. So what that does is see which network are we connected to. So inside MetaMask, we can connect to multiple blockchains here, and they all have IDs. So Ethereum mainnet's 1, Kovan test network I think is 42, and our Ganache is 5777. Right? Yours might be different, but that's mine. So 5777. So we want to get that network ID to determine which network we're connected to, because you always want your app to know, like, hey, are you on the mainnet? Are you on a test network? Are you on Ganache? So we're going to fetch that ID. So let's do that and we'll log it to the console. All right. This will just make sure that we can actually get the connection to the blockchain and that our application can detect that we are connected to the correct chain. All right. So, yep, there we go. If you can see on my screen here, 5777 is logged to the console. You can open your console like this. You can do inspect, go to console if you're in Chrome, which you should be in Chrome if you're using MetaMask here, and see 5777 here. So that works. All right, we logged to the console. So now we can fetch all the accounts that we're connected to from our MetaMask, just like we did in the Truffle console before. Get the accounts, all right? And then we can do console log accounts 0 to get our particular account. Okay, so I forgot an S here. Yep, there we go. There's our account that we're connected to with MetaMask. You can see here 0x2371, 0x271. That matches exactly what's inside of Ganache. Yep, awesome. So we're making some way here. So let me also explain this load blockchain data function. So this is inside of React's lifecycle method component will mount. So basically we can call this function inside here like this, and that's exactly what this does. All right. So now what we want to do is actually fetch our balance. We want to check our ETH balance like this. We can do const balance equals await web3 ETH get balance account 0. And then we can log that to the console. All right, there's our ETH balance. So instead of just logging it to the console, let's actually set it to the React state object. So remember I said that we're going to treat the state object kind of like a database. Well, we have a place for our balance here. So we can store our balance inside the React state object like this. So instead of just logging it, we'll essentially save it. We'll say this.set state, all right? And then we'll say accounts 0, so we saw a second ago. All right, we're gonna update the account right here. And then we're gonna update the balance. And we're also gonna go ahead and store the Web3 connection here. Now, if you're an advanced JavaScript developer, you probably already know that you can, shortcut it like this, but I'm just gonna leave it longhand, especially for beginners watching this video. It makes it easier to understand, okay? All right. So now what I want to do is also make sure that the account exists. Okay. So this will also make sure that the MetaMask has been connected, because sometimes you have to connect MetaMask when you're loading your application. So let's do this. We're going to wrap it inside this conditional that says basically if type of account, is not undefined, then we'll do that what we just said. Otherwise, we'll show an alert and say, please log in with MetaMask. Okay. So now we want to load the smart contracts into the application. We've loaded our account from MetaMask. Now we want to get JavaScript versions of this token and also the bank so that we can call those functions with Web3.js and create JavaScript versions of them in the app. So let's take a quick look at how Web3 creates JavaScript versions of the smart contracts. Okay. So Web3, like I said, is a JavaScript library that lets us interact with Ethereum. We can create JavaScript versions of the smart contracts so that we can call their functions in JavaScript inside of our client-side application. A lot like we did in the tests, a lot like we did in the migrations. But we're going to use Web3 versions. So you create a new Web3 contract like this. You say new Web3 ETH contract, and then you need 2 pieces of information. You need the JSON interface, which is that ABI we saw earlier. Don't worry, I'll show you again in a minute. And then the address, which is the location of the smart contract on the blockchain. Okay. So basically this interface is going to tell you all the functions the smart contract has, what their function arguments are, all the events, all the variables, all that kind of stuff. Okay. So essentially we'll create a new contract for the token. All right. Let me kill all these instructions. Right here, we'll basically create a new contract for the token and also the bank. Okay. So we need the ABI for the token. This is the JSON interface. So we're not going to do these options. Basically, we'll just say the address. The JSON interface is the ABI. So we can say like const token. Okay, so where does this information come from? Well, the ABI is in here. So go to source ABIs, token. You can see here, this is this big JSON object. So nested inside of here is the ABI key. All right. So anything under ABI is the ABI. It's this array with all this information inside of it. So we can go to the top of the file. You can see that token's already imported. So token is this JSON file. That's this entire thing. So we can take this JSON file, all right, and then dig into it and then say token.abi, and that's the ABI. So next, we can get the network. We can get the token address from the network like this. We can dig into here and go to networks and then find the current network we're connected to and then find the address here. Okay. So you do that like this. You say token.networks and then you pass in the network ID, which we saved here. All right, and then we get the address. So this is, you could break this up, do some more error checking and not, like read it out so fast like this. But I'm just gonna leave it that way so it's easier to understand. So the same thing is true for the bank. dbank. And then we're going to change this to dbank. All right. And then we're going to save the dbank address to a variable like this. And then we're going to save all this to the state object like this. All right. So basically this creates JavaScript versions of the token and also the bank. And then it saves all this stuff to the React state object. We want to save the token. We want to save the bank. We want to save the bank address. Okay. So now, like I said, this can get a little bit brittle, and I don't want to spend like all day trying to do advanced error handling. So we're just going to wrap this in a try catch for JavaScript. So basically, if this code fails, we'll catch it and log it to the console and do a window alert. All right. So there you go. Now we've successfully loaded up all the blockchain data to the application. So we'll save this. We'll go back and look at the app. We don't see anything yet. That's okay. We can tell that our information is still there. We can, log the dbank address to the console or something like that. Say console log dbank address. And there you go. Awesome. So it's working. So now let's actually fill out some information on the page. Let's make the front end look nice. Let people use it. Let's add a welcome message here at the top. So we can edit this HTML to lay some information out on the page. We'll say welcome to dbank. So there you go. Awesome. Welcome to dbank. And then again, so all this stuff is in Bootstrap. So Bootstrap gives us these nice classes so that we don't have to write a bunch of styles for ourselves. Yeah, some people don't like it. They like to write their own style sheets, but I'm a coder, not a designer. And especially for these tutorials, it's so much easier just to have, this stuff in here. So we're going to add the user address. So we'll say this dot state account. So basically like saying, welcome to dbank, here's your address. Okay? Welcome to dbank, and then they're saying it's you, right? So the next thing we want to do is add the functionality to where they can deposit into the bank and then wait and also withdraw, okay? So we can add some instructions on the page. Like this, we can say how much do you want to deposit? The minimum amount is this. What we're going to do is actually use tabs inside of Bootstrap. So you can see these tabs already here. We have this tabs thing. This comes from React Bootstrap. So this is an intelligent component that's imported at the top. So you see tabs, and you already have a tab available. Okay. So what we're going to do is create a new tab here. I'm just going to remove this and say, tab like this. So tab event key equals deposit, title deposit. Okay. So we're going to create a new tab like this with this information. So we want to make sure this works exactly like that before we do it. We'll create a new div here. For my tab completion is not working in React right now. I'm not sure why. Sorry, everybody. Normally I have Emmet configured to do tab to completion, and it's not working like I expect. So we'll do this. I'm not really sure why that broke. I need to change my Sublime Text settings. Okay. So we can say, how much do you want to deposit? You see it on the page here. All right. See deposit tab here. We can copy this and also make a withdrawal tab. Just copy this. Say withdraw. All right. And you can say something like, instead of how much do you want to deposit, you could say, you know, do you want to withdraw plus take interest? All right, so there we go. So you have like a deposit tab, you know, how much do you want to deposit, withdraw, you know, do you want to withdraw plus take interest? So there's the tabs, that's how they work. Now we're gonna add information to these tabs to actually deposit funds into the bank and withdraw. So let's go ahead and do that now. All right, so now I've pulled some code in here inside this tab. So we say how much do you want to deposit? You know, the minimum amount is 0.01 ETH. One deposit possible at a time. And then we have a form here to actually do the deposit on the page. All right, so let's just refresh the page here. Click on deposit, and you'll see this come up. How much do you want to deposit? This is the minimum. And then you can put in an amount here, you know, this, et cetera, et cetera. So this won't work yet. Click deposit, like nothing happens. Okay, it just refreshes the page. But I wanted to lay that out on the page. If you want to copy some of that code from the final code solution, you can do that. If you want to pause the video and look and see what I've written, you can look at that as well. Okay, just want to kind of go through this a little faster because I want to get to the important part, which is actually wiring up the form. So I'll just pause and we'll continue. So there's going to be 3 major steps here. We need to configure this input to handle the input from the user. And then we want to wire up this button whenever the deposit is clicked. So we'll configure this on submit right here. You'll see that in a second. And then finally, we'll take that information and update this function to actually call the deposit to the smart contract inside the smart contract of the blockchain. Okay. So let's do this first. So let's go to the input. We're going to update these one by one. So we got to give it an ID first. Okay, so I'm doing this on multiple lines. So ID is going to be deposit amount. So step is going to be 0.01. All right. So the input type is going to be a number so that it knows that you can be a number. And you'll see how this works in a second. So actually, let's go ahead and save it and take a look here. So now if you go to deposit, it's a number, and you can just do boom, 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 and it steps by 0.01. So it knows the number input. And of course, you don't want to be negative. It'll fail if you do that. And then next, we want to give it a class name so that it can look nice. All right, now it looks better. It's actually the full width. And next, we want to give it a placeholder. So you can see that it says, you know, hey, what amount? Yeah, boom, nicey amount. And then you can just do up, down, or you can, you know, 0.05, whatever. All right, and then go up, down from there. Next, we want to make sure people fill in this. So we'll say required. All right. And the last thing we want to do is give it a ref. So we're going to do it like this. Basically, we want to keep track of whatever information the user has put in. So React does that with something called a ref. We basically give it this function. We say this deposit amount equals this. So basically what's happening here is it's storing the information from the depositor and saving it to this deposit amount. This is a function that gets called. It's getting passed into this ref. You'll see in a second whenever we read it out up here. Okay, so deposit 0.01. Okay, so nothing happens when we click it. We want to make that happen. So the first thing we want to do is update this onSubmit handler. So this is a function that gets called whenever this submit button is clicked, or if we hit enter on the form. First thing we want to do is click event e.prevent default. This prevents it from refreshing the page. Click deposit, click, you know, like 1, click deposit, and then you don't see the page refresh. So that fixes that. Next, we want to get the amount. So we'll say let amount equals this dot deposit amount dot value. So that's where you're reading this from. It's basically catching this value that was saved here. So this gets saved, with a ref, and then we read from the ref right here to get the amount that was put in by the user. And we convert that to way like this. So amount equals this, because remember, we convert Ether to way with 18 decimal places. So we can do that like this. It's probably better to use the Web3 utility, but this is fine. And then lastly, we want to take this amount and pass it into the deposit function. Okay, so this deposit function again is up here, and this is where we will actually interact with the smart contract. So let's just see. Click deposit, click 1. So still nothing happens, that's okay. But we can ensure that we are wired up to the deposit function here. We can say console log amount, because it'll only log out if we've actually wired it up properly and passed it in here. So let's just click 1, and we should see 1 followed by 18 decimal places. Yep, boom, there we go. Awesome, it's working. So now we actually want to interact with the smart contract in order to do that. So I'm going to show you how we do that with Web3. So with Web3, whenever you call functions on the smart contract, whenever you do things like create transactions, you have to do send functions. So you do it like this. My method, so contract, like dbank, for example, methods, we fetch the method, we fetch the method name, so like deposit, we pass in the function parameters, and then we say send. So you have to say send after the transaction and give it some options to actually create the transaction. Because if you don't do send, it just returns the function itself. Okay, so I'll show you what I mean by that. So we'll replace this and say like await this state dbank. So that's the Web3 contract that we save from the state object. So methods, deposit, okay, and then we do send, okay. So value is message value. That's the amount of Ether that we want to send, okay, so the amount. And then from, we got to tell it which account it's coming from. So this .state.account, all right. So lastly, we want to wrap this in some basic error handling, which you could probably handle this a better way, but this will work for now. All right. So let's give it a whirl. Deposit. Let's deposit 1 Ether. Let's check our balance first. Go to Ganache, 94 Ether. Click deposit. See a MetaMask confirmation pop up. Click confirm. And boom, there we go. 93 Ether. Awesome, it worked. Very cool. So congratulations, you've just wired your application up to your smart contract and actually interacted with it. So now let's go to the withdrawal part, okay? Because we want to get the money back out. We also want to claim the tokens. Now let's process a withdrawal. So it's gonna be pretty straightforward. Basically, let's just go ahead and replace the tab here with the final code solution. All it is a button that calls the function to withdraw. There's no form. We don't have to have any user input. The user just has to say, I want to withdraw, and then sign their transaction, and it'll give them their cryptocurrency, the Ether, plus the tokens. So here's the button. It's just a submit button with some styling on it. We have this on-click handler. So instead of on-submit, it's not a form, so we don't submit. We just click. So on-click, I would say this dot withdraw, okay? And then we pass in, the data. And then we fill in this withdraw function here to talk to the blockchain. So it basically does the exact same thing that our other function does up here, except it withdraws, calls the withdraw function. So we'll actually move the prevent default behavior up here. So into this, which it could be better than that, but that's okay. But withdraw, we just got to make sure dbank is there. And we say await this state dbank methods withdraw, send from this state account. It's basically the same thing we did here, except we just changed to the withdraw function. All right. So let's save that. Refresh the page, go withdraw. Do you want to withdraw plus take interest? Click yes. Sign the transaction with MetaMask. Let's check our balance before we do it. So 93 Ether, let's click confirm. All right. And boom, there we go, 94. We took our funds out. So now you might be wondering, how do we see our token balance? Well, there's a couple of good ways we can do that. We can go into our app here and then say, let's see here. Or actually, let's do this. Let's go to our ABIs. Let's look at the token. Find this address. Okay. Go to your MetaMask. Click on assets. All right, there's all kinds of assets in here. Let's just click add token, custom token, contract address, and it automatically detects the symbol, the decimals. Click next. And there you go. So you have some tokens. It's a very, very, very small amount. Okay, that's why you see the dots after here. But you could also, you could write a script in here. You could go to the Truffle console. You could do like, I'm actually going to leave this to you as a homework assignment, okay? So you see homework up here, add new tab to check accrued interest. So you can add a new tab. I'm going to give you some hints on how to do it. You could do console log like this. Let's just see the token contract. Say token methods balance of this dot state dot account call const token balance, and then console log token balance. All right. So something's not working here. So token's not defined. Okay. Let's try this. Let's just put it in here. All right. All right, there we go. There's a token balance. You can also convert it to Way. So Web3 utils from Way. Convert to the Ether value. So see, it's really, really, really small. I'll leave that to you as an exercise. All right. So that's a hint on how you can do it. So I'm gonna take this out. All right. We don't need that necessarily. But you could save it to the state here. You could create a new tab down here and then show the interest accrued. But that would really be for interest that you've taken out. But you could check the interest accrued from the bank. You could calculate the time, calculate the interest, all that kind of stuff, right? So that's one idea. If you want to continue out this tutorial and look at how to like borrow money out of this bank, take out loans, pay back loans, handle collateral, you can go to the dbank, go to the different branch, go to borrow lend, and you'll see some more functions inside of there. Let's see here. You can look at the contracts. There's actually borrow and lend functions. So you can see borrow and then pay off. Okay. So you can work on those if you want to. There's tests for those. There's a front end for that. Okay. That's good homework for you to do as well. So you can build this into your own DeFi application. So I hope you like this. Congratulations on getting all the way through this tutorial. As always, smash that like button down below, subscribe to this channel. That really helps these videos out so more people can learn about blockchain. If you're as fascinated with this technology as I am, you like this tutorial, you want to take the next step, learn how to become a real world blockchain developer step by step from start to finish. So like a lot of this tutorial, we kind of like filled in gaps and, copied and pasted some things. But if you want to actually like learn everything for real, like concepts, step by step, create a project from scratch, create a real world blockchain application that you can deploy, out there in the wild, use for your portfolio, land a high paying job, an advanced application like you would build at a job, get you job ready. Like blockchain is one of the highest paying fields in tech right now. Head on over to dappuniversity.com/bootcamp to get started today. I can show you how to do all that stuff step by step from start to finish. I've helped people with zero programming experience become real world blockchain developers in a matter of months. All right, so that's all I've got. Till next time, thanks for watching Dapp University.